Welcome back, Math 7. Today we are starting our new unit. This new unit, or chapter if you will, you can find it from the textbook Math link at chapter 1. And the title is known as Coordinates and Designs. So obviously we are going to start with basic. And the very first concept that we are going to learn, which is today's title, I'm going to refer this as the Cartesian Plane. As you may notice, I am going to do lesson for this entire unit using graph paper. So I like to say when it comes to material that you need, graph paper. There you go. Graph papers. If you prepare that little ahead, it's always beneficial for the learner's perspective. So let's find out what is Cartesian plane first. Cartesian plane is basically a plane that is formed when horizontal and vertical number line crosses. So Cartesian plane is composed of a combination, composed of both horizontal number line and number 2, vertical number line. And we learned about horizontal number line and vertical number line before in integer section. Basically, ladies and gentlemen, the Cartesian plane have to have, like what you see, we are going to call it y-axis, the number line that go up and down. Anything that goes up, you may know, is positive. Anything that goes down, it's negative. And at the midpoint, we have a little cross going on. And we call this horizontal number line x-axis. Anything that goes towards right side is positive, left side is negative. So always know the fact that when it comes to the Cartesian plane concept itself, you have to draw both components. Components 1 deal with our vertical axis, which is y-axis, and horizontal part, you need to focus on x-axis, which is horizontal number line. I want you to focus on those two. Using those, ladies and gentlemen, we will define each of the region. But before we doing that, let me put what I just explained as a little note. First thing first. Like I mentioned, vertical number line we're gonna call this y-axis. Horizontal number line from now on we're gonna call x-axis. So y-axis and x-axis, you guys can combine them together and call it Cartesian plane, which is what you see over there. Also, this midpoint that cross literally between horizontal and vertical, we're going to call this as origin. And origin is always 0 and 0. I'm going to tell you how you can refer this coordinates. I may put that in here. The 0 and 0. From now on, we're going to call it coordinate. Coordinate is a simple way of referring position of a dot. You can think it in that way. Now, here's what I'm going to point it out. Since we have vertical number line, horizontal number line, we are having 4 different regions. For example, I'm going to hide these other area. Y-axis and x-axis can be positive and positive. Then any of those value will occupy this area. On the other hand, if x value is negative, y value is positive, it's going to be located over left upper side. If x and y's are negative and negative, bottom left side. If x is positive, bottom is negative, then the fourth last part, which is right and below part. These are what we like to call quadrant. I'm going to explain about those quadrant a little bit. So first thing first. If, ladies and gentlemen, you have a Cartesian plane, which I'm going to draw in here again. Let's draw a quick example over here. Know the fact that this was y, that one's x. And I'm going to put positive on anything on the right, negative for anything on the left, positive anything that go above, negative anything that go down. This region is called quadrant 1. Quadrant 1. And this is a rule, ladies and gentlemen. Anything that go positive for horizontal and positive for vertical, we're gonna find any coordinate that have positive and positive, and we're gonna call any coordinates position that has positive and positive, say those coordinates belongs to quadrant 1. On the other hand, what about anything in this region? This is, seems like ink is out, so I'm gonna put that. We're gonna call quadrant Roman numeral 2. This is a position where, and this is where I'm going to tell you a little rule. We always put x position first. So when we talk about coordinates, we always refer x position first and y position. So x position is on the left, y position is above, so negative and positive. Other part, anything that belong bottom left, we're going to call it quadrant with Roman numeral 3. Quadrant 3. These are the ones that basically have any negative and negative position. So horizontally, left and bottom, negative and negative. And our last section, which is bottom right corner, we're going to call quadrant and Roman numeral 4. This is a region where every coordinate have positive for the first, negative as a second. That's a fancy way of referring right and bottom. So these regions are something that you need to understand from today's lesson. We call it coordinate grid and coordinate location. Let's do a quick classroom example. I want you to draw coordinate A, coordinate C, coordinate B, coordinate E and D, And my question is, identify all coordinate position and quadrant. Imagine this is a question. We need to identify all of the coordinate position and quadrant. Let's start alphabetically. A, B, C, D, and E. A, let's start with that first. You always start from the center, origin. And in order to get to A, horizontal first and vertical later. Horizontally, I go 2 to the right. So I'm going to track that a little bit. Although it's not entirely necessary, but since it's the first time, we move 2 to the right and 3 to the up. So that's a fancy way of saying my coordinate A, always put horizontal value first. 2 to the right means positive 2. 3 to the up means positive 3. So 2, 3 with bracket and bracket close. This is our coordinates. I am also going to find out my quadrant. As you may notice, this is positive and positive, right? So you can say this is belong to quadrant 1. We can conclude in this way. Next example, B. You may notice that, unlike the previous one, I have to move 1, 2, 3 to the left and 2 to down. Fancy way of saying 3 to the left is minus 3, comma, 2 to down means negative 2. So negative 3, comma, negative 2, which is fancy way of saying this is belonging to quadrant 3. Anything that belong left and bottom is quadrant 3. C. When it comes to C situation, C is, in order to get there, we are traveling from the center, 1 to the left, 1 to the up. Fancy way of saying 1 to the left is negative 1, 1 to the up means positive 1. There you go. And this is a region where I have negative and positive, or left upper corner. We're going to call this quadrant 2. Always refer the previous note. D. This is the one that is a little tricky. I'm going to do E first, if you don't mind. E. In order to get to this position, start from the center. How much do I need to move horizontally? 2 to the right, 4 to the down. So that's a fancy way of saying E is positive 2, negative 4. And that, ladies and gentlemen, is basically known as quadrant 4, where we have positive for x value, y value for negative. Now, D, our final position, and I'm going to explain to you why this is a tricky one. First thing first. Compared to the origin over here, you only travel vertically down by 2. You're not moving either right or left. So in that situation, my horizontal movement is 0. So as you may notice, I put 0 at the first number section, or blank. But second part, I'm moving 2 to the down, so that's negative 2. Whenever you have this situation where x value is 0 or y value is 0, we're going to conclude that it doesn't belong to any quadrant. So, no quadrant. It doesn't belong to any quadrant. Even if some people say, oh, Mr. Kim, this is Roman numeral 3 quadrant position and this is 4th quadrant position. Can I just put 3 and 4 together? No, don't put any quadrant. This is what we call the coordinate lies on y-axis. That's what I'm going to call. So, A, B, C, and D, we can locate any of those. Now, when it comes to advanced type of question, at this point, you don't even need to draw any of a coordinate. You know that when it comes to quadrant 1, that's positive and positive position. Quadrant 2, that's negative and positive. Quadrant 3, that's both negative and negative. Quadrant 4, that's positive and negative. So as long as you know this row, you don't actually have to draw the coordinate. You can actually answer the question just like that too, if you know some coordinate. Like for instance, a new A's position, new B's position, new C's position. I'm going to create some random number like negative 10, 9. And the other one, 3, negative 2. And negative 4, negative 4. Let's do one more. And this is 5 and 0, something like that. Let's look at each situation. Can you see that my first situation, if I just look at the sign, negative 10, that's going left, so that's negative, and positive 9, that means it's going up. Is there a quadrant that satisfies negative and positive? Yes, we do. This is quadrant 2. So as you can see, as long as you know the sign rule over here, you don't have to actually construct the graph. That's my main point. B, on the other hand, 3 and negative 2. This is positive for the first, negative to the second. Is there any quadrant that belongs for that? Yes, we do, which is quadrant 4 over here, which is positive and negative. There you go. What about negative and negative? That's quadrant 3. This is 3, by the way. It's kind of hard to show. And 5 and 0, as you may notice, my y-axis has no positive or negative, or I like to say technically neither positive or negative. So when it comes to D over here, I can conclude that there's no quadrant belong for this one. That is today's lesson. Shortly after, you will see my homework question.